Hello again. It's another exciting adventure in Java programming. If we look at ye old syllabus, we're at the week of the 17th. We'll be starting loops and files this week, chapter 4. I've uploaded the slides already, and I'll upload the video after I've got it recorded. We also need to talk about programming project 2, and also I will give you a brief review of the midterm as well. So we need to talk about that. Now, next week, the week of the 24th, there is no lecture, so don't sit waiting on a lecture to be uploaded, because there won't be. The week following will be the midterm exam. The days and times are still to be announced. I have to obtain a room and determine exactly what days and times we need to reserve, so that as many people as possible can try to make it. If it's absolutely not possible for you to make it on the day or days that we choose, days and times, then I will try to arrange for something else for the outliers. So also, if you're taking the class from extremely far away, we have to work out something with a proctor. So that would be a person that will administer the test to you. So we'll be starting on chapter 4 today. Chapter 4, loops and files. I have Eclipse fired up. I just got new hardware this week. They gave me a new laptop because I was due for one. So if anything goes a little bit awry, it may be because the settings aren't exactly what I should have them at. There are a couple gotchas that I've encountered so far. One of which, not the least of which, is that they apparently forgot to install Office 2013. So that was exciting. But they'll be installing that back tomorrow. I do have Office 2010 though, so I can still do the PowerPoint presentation. So we've got loops and files, starting out with Java. The 5th edition again, chapter topics for this week. Chapter 4, well, this week and also the week that the week after the week we come back, because we will continue loops and files then. I'll try to do a brief review. You might have to review the lecture itself. But Chapter 4 discusses the following main topics: the increment and decrement operators, the while loop, using the while loop for input validation, it's a topic we'll talk about, the do while loop, the for loop, running totals and sentinel values. We'll talk about nested loops. We'll probably stop around here for today and then save the rest of it for the week after the midterm. But then we'll also have the break and continue statements, deciding which loop to use of the ones that are available to us, introduction to file input and output, and also generating random numbers with the random class. Okay, so before we get into actual looping, repetition, we should discuss the increment and decrement operators. There are numerous times where a variable must simply be incremented or decremented. In other words, this means adding one or subtracting one. It's a very, very common operation. Increment means to increase a number's value by 1, and decrement means to decrease a value's number by 1. So the Java has, like many programming language, actually has some special operators, unary operators, meaning they only take one operand. You put one variable here, and then you call the increment operator on it. Or you can use it in prefix notation, and if they're all alone on their own line, then both of these are equivalent, and so are these two. So we're going to take a look at an example here. I'm going to start a new project. We'll call it lecture 7 examples. Okay, so lecture 7 examples. I'm going to add a source file class. This one's going to be called increment decrement. basically from the book. Might make slight modifications as we go along. But we've got public static void main string args. Okay. And in this case, if you want to look in the book or follow along in the book, it's on page 194 in section 4.1. This one is just a brief and basic example of how to use the increment and decrement operators in Java. It's actually pretty straightforward. And int number equals 4. Then you're going to display the value. So, display the value. I'm going to do system.out.println. I'm going to say number is number, and then we're going to say system.out.print line. We'll just put about the increment number. Okay. So then we're going to say number plus plus. That's where the incrementation occurs. And then you're going to display the new value. System.out.print line. I'll probably want to fix that up here. Okay. System.out.print line. Now the number is now let's say system.out.print line about the decrement number minus system.out.print line now number is. Okay, so we've got our code here. We start out by declaring the variable, integer variable named number. That's its identifier. This is the data type, integer. We store the value 4 in it. So again, a variable is basically just a memory location that it's like a little box, and you're storing a value in it. So at the beginning, the number should print out numbers 4. Then I print out about to increment number. This programmatic statement right here, number plus plus, will take the value inside of number and store it back in itself with 1 incremented. And then the same thing down here with the decrement. This is equal to number equals number minus 1. Alternatively, you could also do this. Number plus equals 1. That's another alternative. Using the compound operators, number minus equals 1. All right. But it's so common that the unary operator is often is the quickest way to increment and decrement. So let's see what happens if we run it. If we look at the values down here, it says number's 4, about to increment the number, now the number's 5, about to decrement the number, now the number's 4. So we incremented it here, it became 5. We then decrement it here, and then the value is 4 again. So again, pretty straightforward. When an increment or decrement are the only operations in a statement, there's no difference between the prefix and postfix notation. So again, if we wanted to, we could also, an alternative would be to put plus plus number or minus minus number. You don't put any spaces between them. This is called the prefix notation, and then the one below it is postfix notation. I'm going to actually do that. The prefix notation and postfix notation, or post-increment and pre-increment notations. When used in an expression, the prefix notation indicates that the variable will be incremented or decremented prior to the rest of the equation being evaluated. Postfix notation indicates that the variable will be incremented or decremented after the rest of the equation has been evaluated. Now, I'm not going to use their example with prefix.java, but I will declare a number 2. I'll set it equal to 0, and we will mess around with this for a second. You know what? Actually, I guess we will. We will create an extra Java file. I'm just going to make my own though. New class. We'll call this post pre. Finish. Oops. Again, I'm just putting them in the default package just for brevity's sake at this point, but you probably want to use a non-default, oops, I was going to say void thing. You want to use a default, or non-default package name. So something like com.profjpball.com or .postpre or whatever. So we'll say int x equals 0, int y equals 0. We'll actually make x to be 10. And let's see what happens here. If I say y equals x plus plus, what do you think x is at this point, and what do you think y is? Let's see. System.out.println, x is equal to x, and system.out.println, y is equal to y is. Let's run this. If we look at the bottom, we see that x is 11 and that y is 10. Well, why isn't y taken to the value 11 as well? Well, with postfix notation, the value of x is incremented after y is set to x. Okay, so what happens is, you can think of it this way. Look at it this way. You have y equals x. There's no plus plus in this section. Y equals x. Then, after that is done, immediately after that's done, x plus plus is performed. Now, we can take another example. Let's say int w equals 20, and int z equals 0. We'll say that this is the prefix example. Postfix example. In the prefix example, what we're going to do is we're going to say w, or z rather, equals plus plus w. Now we're going to ask the question, what is z equal to? What is w equal to? Well, system.out.println, we can say that z is equal to z, and w is equal to w. If we run it this time, we'll notice that x is 11 and y is 10, just like before. Now, z and w, we get a different situation here. Well, y, in this case, is z set to the same value as w's ultimate value. Well, what happens with prefix notation, if they are not, if the prefix and postfix are not part of an equation like this, or an expression of some sort, then it doesn't matter. But if they are part of an expression, then since this is prefix, that means that it gets done first. Okay, the plus plus is done first to the w, which takes it up to the value 21. Then the value 21 is stored in z. And just so you know, this whole thing right here, very many companies use that as part of their programming test before you get hired, or as an interview question. Okay, so they ask the difference between prefix and postfix. You should look into this. Okay. The example, they talk about the difference between prefix and postfix in the 5th edition on page 196. So I highly recommend looking over that. Okay, the next thing, we're getting into looping now. Java provides what they're calling in the book different looping structures. Now, we need to be familiar with terminology. The terminology that we're going to be looking for at this point is that we just got done with decision structures in the last chapter, chapter 3. Decision structures, that's what I would refer to as selection control structures. Okay, selection control structures are sometimes branching structures, but selection control structures is what a lot of literature refers to the if statement, the if else, and the switch statements. Okay, the if single selection control structure, the if-else double selection control structure, and the switch multiple selection control structure are all selection control structures or decision structures. In the book, they call the while loop, the do while loop, and the for loop, which are three of the loops we will talk about, the three that Java provides. They call them looping structures. In a lot of other literature, you will hear the term repetition control structure. You might also hear the term iterative control structure because they iterate. Now, whereas a selection control structure will either do something or not, or pick between alternatives based on the truth of a condition, a looping structure or repetition iteration control structure, these will continue repeating until a condition is false. So as long as the condition is true, the statements will execute repeatedly. The while loop takes this form. It has the keyword while, an open parenthesis, a condition, just like you would put a condition for an if statement, and a closing parenthesis. Then the body of the while loop has curly braces. The curly braces are not required if you only have one line of code that is attached to the while loop's header. Okay, this is called the while loop's header. This is good programming practice, in my opinion, to put all of the code inside of curly braces, even if there's only one line. The while loop is a pre-test loop. It's a pre-test loop, which means that it will test the value of the condition prior to executing the loop. All right, so care must be taken to set the condition to false somewhere in the loop so that the loop will end. Now, they're making it sound awfully direct here. You may not be setting some variable directly, some variable to true or false. You don't need a Boolean variable necessarily. But the condition, the loop continuation condition, which is what will be up here, the loop continuation condition, must be false eventually. If you do not, if it never becomes false, then you end up with what are called infinite loops. Infinite loops. This is considered a very, very bad thing, especially in released code. It can cause programs to crash because it'll keep looping and they'll hang. The program will hang, and eventually you or the operating system will kick the program's butt and tell it to get out of memory because it realizes it's stuck, it's frozen. A while loop will execute 0 or more times. If the condition is false, the loop will not execute at all. Now, what this means is if the condition is false going into the loop, so let's say you say while 11 is less than 10, that's never true. So that means that the statements will never be executed in the while loop. Let's do an example. We're going to make another source file. We're going to call it while loop. Hit finish. All right. Public static void main string array args. Okay. This while loop, we're going to set a number to 1. While the number is less than or equal to 5, we're going to do something. Often I'll put comments at the end of my loops because if you start getting a bunch of curly braces going on in here, it gets more and more difficult to track what belongs to what. Now, you will notice that programs like Eclipse give you a little bit of a hint here. If you click right after one of the curly braces, it actually boxes the other curly brace. But if we look inside the while loop, we're going to do this, system.out.println. Well, we'll do hello. We'll say hello. Okay. Now, could I stop here? I could, but I'd end up with a program in an infinite loop. It's not pretty. So the reason it would be an infinite loop is because the first time through the loop, it would ask the initial value of number is 1, and say is 1 less than or equal to 5. That's true. Okay, execute it. Do it again. Is 1 less than or equal to 5? Yes, of course. Do it again. Is 1 less than or equal to 5? Yes. The 1 is never changing. The 1 is never moving towards the loop terminating. So that means this would continue forever and ever and ever. Theoretically. The memory operating system, something would eventually kick it out. So we're going to have to move toward termination of loop. So the while repetition control structure, the while loop, in this particular one, we're going to print out hello, increment it to 2 the first time through the loop. It'll say is 2 less than or equal to 5? Yes. 3 less than or equal to 5? Yes. 4 less than or equal to 5? Yes. 5 less than or equal to 5? Yes. Then it'll be 6. Is 6 less than or equal to 5? No. So it will skip over the body of the loop and continue afterwards. So let's print at the end of this while loop. We're going to put system.out.println. That's all, folks. All right, now we're going to run it. And you'll notice down at the output you have hello, 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 hello. It happens 5 times because we started at 1 and went up to including 5. And then it says that's all, folks, because that's right outside the loop. So this is very useful in situations where we need to do the same thing over and over again, but we don't want to we may not know ahead of time how many times we need to do it, or in some cases, like this one, even if I wanted to print out hello, I could do a copy and paste method, but what if I want to change the message to hello world? I'd have to change it in every location. Anytime you're doing copying and pasting and cutting and things like that, a lot of times that's a red flag when you're programming that you might be doing something wrong. There might be a better way to do it. Not always, but it's a good hint. I'm going to say this. I'm going to say hello from iteration, and then I'm going to write the number out. So I'm going to just put number from iteration, then it'll print out the number. So if I run it this time, the first time through the loop, it says hello from iteration number 1. Second time it says hello from iteration number 2, 3, 4, 5. And then you're out of the loop. So that's all, folks. Why didn't we print out 6? Well, when the number got incremented to 6 here, it went back up to the top of the loop and tested the loop continuation condition. Is 6 less than or equal to 5? No. So that means it never got into the body of the while loop and therefore started here and then got to here, where it says that's all, folks. So we'll learn more about loops in just a moment. But let's go back a little bit and think about what we've learned so far. When you write code in sequence, we call that sequential or linear control structure. And that's what we started with at the very, very beginning when we started doing very basic things. Print this, do that, print this, get that input, print that output. This is all sequential. Then you have a second type of control structure, the selection control structure or decision structure. That involves the if statement, if else, switch statement. This is if you have to pick between or pick among different options. Okay, you might have 2 options and you'd pick between them. You might have 3 or 4, you'd pick among them. So that would be the selection control. So you have sequential control, selection control structures, and then you will have what we're just learning now, which is the repetition control structure, also known as iterative control structures, and as the book describes them, just looping control structures. Typically, when you're talking to other members of a programming team, you're just going to call this a while loop. You're not going to say a while iterative control structure or a while repetition control structure. These are called loops. In most academic literature, though, I'd say it's probably divided between the terms looping structures, iterative control structures, and repetition control structures. So try to memorize and become familiar with those terms. They're very important. They could end up on a job interview question, or they could end up on a test. Wink, wink. All right, so the next thing we're going to look at is the flowchart for the while loop, very similar to the activity diagram in UML. It's similar in that you have similar to a selection control structure, like an if statement, in that you enter it, and then you have to make a decision. That's what this diamond shape means. You have the Boolean expression. It asks a question. Is it cold outside? Then if it is, you do this. Keep going, keep going, keep going. If it becomes warmer, then that's set to false, and then you exit. Since the weather we've been having in Michigan, that's kind of on my mind right now. So maybe it's stay inside, stay inside, stay inside, stay inside, stay inside. Oh, okay, I can go out now because it's no longer cold. Whatever the Boolean expression is, you go and do the statements. The difference here between the selection control structure and the selection control structure, like an if statement, switch statement, or if else, and the looping structure, like we have here, is that it actually goes back up and re-enters the asking the question again, and then re-enters the body of the loop if the condition is still true. So this continues. In order for a while loop to end, the condition must become false. This loop right here will never end. The reason is because you initialize the value of the variable x to 20, and then you say while x is greater than 20, do this. But you never move x, you never decrease x's value so that at some point it won't be greater than 0. So that means the variable x never gets decremented, so it will always be greater than 0. Similarly, if we go back to our while loop example here, if I were to comment out or take out the number plus plus and run it, you'll notice at the bottom we end up with, it's kind of hard to see here, but you end up with a big mess. I'm going to terminate it with the big red button here. But you notice it printed out hello from iteration 1 like a bajillion times. That's because it never changed, and it would have continued had I let it. To end it, you have to make sure that it moves toward the, in some fashion, the the termination of the loop, so that the loop continuation condition is false. All right. So if I were doing this example, again, you don't have to increment. You can use some scenario where you decrement, like in this one. You start at 20 and you're supposed to go down. Adding x minus minus to right below here with the semicolon at the end, of course, would fix this problem, and it would no longer be an infinite loop. But an infinite loop is a logic error that occurs pretty frequently if you're not careful. So this is the fixed version that decrements the x so that it gets towards the continuation condition. So if we put plus plus here instead of minus minus, this would still be an infinite loop, because it would be moving away from the termination condition of the loop. In other words, it would be moving away from the loop continuation condition ever becoming false, and we don't want that if we want it to ever stop. Block statements and loops. Curly braces are required to enclose block statement while loops. So, for example, like block if statements. We talked about that before. You need the curly braces around any block statements. Now, as a matter of good programming practice, I'm going to recommend, even if you have one statement, that you put blocks around it. All right? So, as we continue, we're going to discuss using the while loop for input validation. So in this example, we see that input validation is the process of ensuring that user input is valid. Okay, you're taking the input and you're determining, is it correct? This is an example. If you print out, enter a number in the range of 1 through 100, then you take the input, and you can use the while loop to continuously ask the user to try a different number before they go on if they entered an incorrect number. Now look at the condition here. We're using relational operators here, number less than 1, and also the relational operator number greater than 100. And then we use the logical OR. Okay, so you're saying if the number was less than 1 that they entered, let's say they entered a -5, that's obviously not in the range. Or if they entered 110, that's obviously not in the range. So either way, you tell the user that number is invalid, enter a number in that range. If they still persist in entering the incorrect number, it'll go to the loop, test the condition, and the condition will still be true. And it'll keep asking them until they enter something correct. So if they enter 50, that's within the range. So is 50 less than 1? No, it's not. So that's false. Is 50 greater than 100? No, that's false. So false or false is equal to false. Let's do an example. We'll do soccer teams. I'm going to add a new class here. I'm going to call it soccer teams. not to be confused with Socrates. Soccer teams. Public static void main string array args. Okay. If you're following along, this is it's on page 205 through the next page, I believe. So final int min players equals 9. Final int max players equals 15. So we're going to have the max and min, obviously, and then we're going to say number of available players, its team size, number of players per team, its team, number of teams, that should be teams, not team. Teams, space that over there a little bit. Okay. Now, if you'll recall, what does the keyword final mean? The keyword final is the way to indicate that a variable is a constant in Java. That means that once I've established this value here, I cannot change that value again. I can't later on just say min players equals 12 or something like that. You can't do that. You cannot change the value. Okay. And we're going to have another integer called leftover. And we're going to have, I'm going to put some spaces here, number of leftover players. And then a string input. This is going to hold the input. Okay. So far we have a few variables. This is a little bit more of a complex, a little larger program. The first thing we're going to do is grab the number of players from the user, number of players on the team. So we're going to say JOptionPane dot show input dialog, and we're going to put enter the number of players per team. Then we're going to take team size and set it equal to integer dot parse int. We're going to pass it the input that the user entered. So team size will be set at that point. Now we're going to say validate the number entered. Okay. So what does this mean? While team size is less than max or min players, okay, or team size greater than max players, so if they enter a number, say 7 or 6, that would be lower than the min players. If they enter a number greater than 15, then that would be greater than the max players. So that means we want to ask them again. And we're going to put in the option pane, JOptionPane dot show input dialog. This message is going to say the number must be at least, okay, plus symbol there. And we're going to have min players and no more than max players. Okay. And you can actually put a period and you can put a \n to add spacing. Enter the number of players. Okay. Again, team size equals integer dot parse int on input. Okay, so that will take them through. It'll continue the loop if they do not enter a correct value. Then we're going to get the number of available players. We're going to put input equals JOptionPane, show input dialog. This message is going to be enter the available number of players. And then you're going to set players equal to integer dot parse int and pass it the input again. So again, why do we need to do this parsing? That's because we cannot compare values as strings when we want to treat them as numbers. So we take players, take whatever the user input. We're just using input as a generic string that obtains whatever input they put in there. And we'll assume they put a number here, players I'm going to validate the number entered. So in this case, we're going to say while players less than 0. That means if they entered less than 0, then we're going to tell them they need to enter 0 or greater. Option pane dot show input dialog, and we'll say enter 0 or greater. Okay. And players again equals integer dot parse int on the input. Right? So these are two different occurrences of input validation. All right. So you've got the top one that determines if the team size they entered is correct, and then the other one is number of players, available number of players. If it's less than 0, then that's an invalid value. Then we're going to calculate the number of teams. Teams equals number of players divided by team size, and calculate leftovers. So this is going to be leftover equals players modulus team size. Now, this is crucial to your understanding of what the division and the modulus operator do. If we pay very close attention, teams equals players divided by team size. These are all integers. So what's going to happen with them? When you divide players by team size, what if I get 10.5? It's going to cut off the 5. Okay, that's the 0.5 part. So that means it's just going to say 10 teams. Well, we also know that that means that there's got to be some sort of leftover, or it wouldn't have calculated that way. So to calculate the leftover players, you use modulus. This is very similar to when maybe in elementary school you learned how to do division and you talked about remainders. All right? So before you really probably before you dealt with decimal points and real numbers like that, you learned how to find the quotient of a division problem. That's what's done here, the quotient. And then right here you find the remainder. That's what the modulus operator does. It finds, well, how many players are left over. Right? So if you end up with 6 teams, and then you go down here, you might calculate it and find that this will divide by the team size, and it will give you maybe leftovers of 2 or 3. There's not enough to make a full team. All right? If there's an exact number that divides team size evenly, then that means you won't have any leftovers. So let's display the results now. Display the results. Right here we're going to say JOptionPane dot show message dialog. We're going to put null, and then we're going to put there will be. We have to put the variable teams, and then teams with. Okay. Next line. So with leftover. Yes. Players. Leftover. Okay. It's pretty good so far. Close parenthesis. Okay. And then, since we're using JOptionPane, we've got a couple things to consider here. System.exit. That's required. In order to use the JOptionPane, make sure that you import javx.swing.joptionpane. Make sure that is imported. If you don't, then it will not compile. All right, let's run it. Let's say we want to enter 4 players per team, the number between 9 and 15. Let's say we enter a 2. You'll see the number must be at least 9 and no more than 15. 7. Oh, that's right. The number must be at least 9 and no more than 15. So 16, right? No. It has to be at least 9 and no more than 15. Okay, well, we'll do 12. All right, good. Enter the available number of players. We're going to put a negative 140 just to see what it does. It says enter 0 or greater. What about negative 5? No, enter 0 or greater. Okay, well, 142 players in general. So it'll say there will be 11 teams with 10 players left over. Kind of cool. Right? So you could probably take this, you could probably see how you could use this with pretty much any sports or game, chess tournament, Magic the Gathering, whatever your poison is. I'm sure you would be able to use this particular program in something similar. Okay, so let's we can close that one, and we'll continue here. The do-while loop is what we call a post-test loop. Post-test loop, whereas the while loop and the for loop are pre-test. We haven't gotten to the for loop yet, but the while loop we just saw was pre-test because it checked the condition before it did anything in its body. Do-while is post-test, meaning it will execute the loop and then it will test the condition. So it does whatever's in the loop prior to testing the condition. The do-while loop, sometimes called a do loop, takes the form do, keyword do, curly brace, whatever statement you want to execute, and close curly brace, just like a while loop. But the difference is you put the keyword while after it, and you then put the condition, and then you must put a semicolon. Okay, that's required. Let's do an example. We'll do source here, class, we'll call it test average 1. All right. Public static void main args. All right. Okay. For this one, we're going to declare some scores. Score 1, int score 2, int score 3. We're going to have a character, char repeat. This is going to determine whether we repeat the loop or not. And input. Let's say system.out.print. And I'm going to say this program calculates the average of 3 test scores. Right? So far, so good. Create a scanner. Now, how do we create a scanner? Well, we can say scanner keyboard equals new scanner system.in. Now, the problem here is it doesn't recognize scanner. Well, hover over it. We would import java.util.scanner, and that will allow us to import the scanner. Make sure you memorize the library that the scanner is in. Okay, memorize the library that the scanner is in. Java.util. Okay? Alright, are you hearing me? Memorize the library the scanner is in. Alright, it could do very well in some circumstance in the future. Okay, so you've got do, and we're going to set it up so that it's a while repeat is equal to y or capital Y. I'm going to say do while repeat is equal to capital Y or repeat is equal to lowercase y. Right? Now what do we put? We haven't initialized the repeat yet, so we haven't gotten any values yet. Okay. So in the do while loop, we're going to put system.out.print, enter score 1. You're going to put this, you're going to say score 1 equals keyboard dot next int. I'm going to say enter score 2. Enter score 2. Enter 2. And then you're going to ask them to enter score 3. Enter score 3. Keyboard next int. And you're going to calculate and print average. Average, which we currently didn't make a variable for. I think we're going to need that. Double average. I missed that. double, oops, at the very top, we're going to put double average. It's going to say average is equal to score 1 plus score 2 plus score 3 in parentheses divided by 3.0. It's important that you put 3.0 because we have to have it do what we call real number arithmetic. It has to do real number arithmetic. Then you're going to print a out.print line. You're going to print out the average is the average, and then you just put on an extra line. Print line that has no parameters, so it just prints. Right? Once you do that, you're going to say, does the user want to average another set? We're going to put system.out.println. Would you like to average another set? I'm going to say system.out.print, not print line. We're going to put enter y for yes or n for no. Technically, they could put anything that isn't a y, and it would actually work. We're going to say input equals keyboard.next line. Then you're going to say repeat equals input.char at 0. Now what that does, that is a string method. Okay, that is a string method that allows us to access the first character in the string. So you can think of a string as a collection of different slots. I think we talked about this before, but as a refresher, you can think of the string as a bunch of different slots, like an apartment building, and it's got different apartments in it. The very first apartment or the very first letter is at location 0. So by this point, we have established a value here. Let's run it and see what happens. Down in the console, we'll say we have 100, an 87, and a 78. All right, well, I got an exception. Starting index out of range. Let me see here, char at. Would you like enter another set? I think it's being interfered with at some point. Okay, input equals keyboard.next line. Weird. Okay. It's live television, so you can figure this out here. Repeat equals input.char at. Okay, after it should be grabbing the keyboard input. Let's try this again. Okay, so we're going to do 100, 67, 87. Yeah, it doesn't wait for the keyboard input, so that's not good. Let's do, since it printed, I hit enter, so I think it's interpreting my enter. That's not good. We can figure it out though. Okay, so we got, would you like to average or put another test score? Input equals keyboard.next line. Input at equals char at. I'm going to pause this just for a second, and I will fix it, and we'll get back to it. Okay, I think we've figured out what's going on here. When the user inputs the integer here, they hit enter, so that actually generates an additional new line right here. So what happens is when the input's waiting for a next line, it'll actually pull that new line, the next line, so you'll never actually be able to enter the input, so that's not good. So what you got to do is you have to actually consume that new line. Now what we're doing here is we're not actually returning the value, we're obtaining it. We're just going to run it and see. Let's see if this works. 78 and 87. Okay, now it's saying yes or no. We'll put yes. We'll do it again. 60, 76, and 100. Okay. We'll put no. All right. So it seems to be working this time. Yeah, the whole problem with that is you have to make sure that if you have any extra enters going on here and you're waiting to input more data, then you need to consume the extra new line. Okay, because there was a new line here. It calculated all the averages, it went hurdy-durdy-dur, and then when it got here, it actually interpreted that when you hit enter over here, it assumed that was the value you wanted. But it's kind of live television. I just wanted to go through this. After I figured out what it was, it only took a couple minutes. I realized that I had neglected to consume that. I thought I typed it, apparently didn't. So you will probably come across this at some point, so it's a good thing to keep in mind. All right, so the do while is post-test, and you do these statements first. Then you test the condition. If it's true, you go back and do the statements again, etc., etc. So the do while loop is guaranteed to occur at least once. The next loop that we're going to look at is the for loop. The for loop in section 4.5, this is another pretest loop. The for loop allows the programmer to initialize a control variable, test a condition, and modify the control variable all in one line of code. The for loop takes this particular form right here. You have for, open parenthesis. You have initialization right here with a semicolon. Space, test, semicolons. The space isn't really necessary, but it's good for readability. The test is right here. This is the conditional test right here. And then an update of some sort here. Then you do your statement or statements down here. The for loop looks like this. You do the statement, update, go back, Boolean expression, you test it, do the statements, update it, go back, etc., etc. And then when the Boolean expression becomes false, you leave the for loop. The initialization section of the for loop allows the loop to initialize its own control variable. The test section of the for statement acts in the same manner as the condition section of a while loop. And then the update section of the for loop is the last thing to execute at the end of each loop. Okay, so we're going to do a little bit of an example here. This one is the squares example from on page 213 in the book. So we're going to call it squares. New class squares. Okay, enter. Public static array name. So arbs. Okay. Into number loop control variable. System.out.println number squared. Okay. System.out.println. Put it all the way across. Make a little bit of a line here. Then you're going to put a for loop. For number equals 1, number less than or equal to 10, number plus plus. Now, we could have actually just as easily put int number equals 1 right there, but you can also set it up here too. All right. So for this for loop, we're going to put system.out.println, and you're going to put in here. You're going to put number plus, you're going to put the \t plus number times number. So the times is going to automatically be interpreted not as a string operation, as a mathematical operation. In other words, it will multiply these two numbers, which will be the number by itself, and then it will print them. So notice that we have the initialization right here. We then have number less than or equal to 10. That's the test condition. And then number plus plus. So it starts at 1, goes all the way up to 10. When it gets to 11, this condition will be false. Or I'm sorry, this condition will be false. So it will break out and stop the loop. And we can look down here in the console and we'll notice that we have the squareds. Oops, I guess I should probably spell that right. You have the squared values all the way down here. 1 squared is 1, 2 squared is 4, 3 squared is 9, etc., etc. all the way up to 10. So you have all the squares. That's pretty straightforward. Hope that makes sense. The next thing we're going to do, I'm going to actually take a quick break, and then I'm going to come back and finish this. So I suggest you do the same if you haven't already, but you can pause me at any time, so that's the beauty of online learning. I'm going to pause this, and we'll come back in a bit. Okay, so now if we continue on here, the initialization section of the for loop is optional, however. It is usually provided. Typically, for loops initialize a counter variable that will be tested by the test section of the loop updated by the update section. The initialization section, which is the first section, can initialize multiple variables. So you could, if you wanted to, initialize multiple variables. In here, for example, this is what they're calling the initialization section, the test section, and the update section. Variables declared in this section have scope only for the for loop. So if you declare them in the initialization section, for example, if I put right here, if I say int number, I could get rid of this one right here. And you'll note that the program does the same thing. If I needed to access number outside of the loop, though, I would be in trouble because it's declared and only has scope within the loop. If you need to access it outside the loop, then you need to declare it outside the loop, and then you can initialize it there at the loop header anyway. So the update expression is usually used to increment or decrement the counter variables declared in the initialization section of the for loop. The update section of the loop executes last in the loop. So the update section may update multiple variables, just like you could declare or initialize multiple variables. Each variable updated is executed as if it were on a line by itself. So how do we modify the control variable? You should avoid updating the control variable of a for loop within the body of the loop. This is unlike the while and do while, where you do actually do that. So in this case, you probably want to just leave it in the header of the for loop because that's exactly what it's made for. It's updated in the header of the for loop automatically, right, or well, concisely like this right here. You don't want to put, say, number plus plus or number times 12 down here, number equals number times 12 or what have you, because that could cause strange behavior later on or something you may not expect. If you do that, it could make it difficult to debug. Okay. This is an example of multiple initializations. If you do multiple things in here, you just separate them by commas. Okay, not semicolons. Semicolons separate the sections. So you have the initialization or declaration and initialization right here, separated by commas, two different variables. Then you have the test conditions here. You can link them not with a comma this time, but with a logical operator such as or and. And then you have the update section, which is separated by commas there. Note that the only parts of a for loop that are mandatory are the semicolons. Okay, this seems kind of silly. It is silly. I've seen people code this way, and I don't like it. But you could actually treat the for loop just like a while loop. You could put an if statement in here that will break out. We haven't talked about break or continue. That's the next session. But you can also use loops to take running totals. Running totals are actually very, very useful because they're actually used very frequently, is that you go through a loop and you actually total up items over and over again. Different items in a list, for example. So imagine needing to keep track of total user inputs. We're going to create a file here, new class, and we're going to call it total sales. All right. For this one, we're going to use the decimal format in the J option pane. So I'm going to import java.text.decimal format. I'm also going to import javax.swing.J option. option pane. All right, that's too many semicolons right there. Okay. So in here, public static void main. All right. Oh, we gotta put string args. Once we do that, we're going to declare a variable named days. Make sure to put a semicolon at the end. Double sales, double total sales, and a string input. Create a decimal formatter object. So a decimal format, we're going to call it $. There's new decimal format. And you're going to put, okay, number, comma, number 0.00. Okay. So if these numbers exist, it'll put them or not. With the numbers like the zeros right here, the placeholders, it'll put either 0 or the number if there is a number available. So once you have that, you're going to get the number of days. The option pane. Show input dialog. For how many days do you have? Okay, do you have sales figures? Okay. Once you get that, you have to parse it. This is very important. The parsing part. Do not forget this if you're getting data in from a J option pane, for example, or another GUI interface, because the data they pull in are coming from things like basically a text box, and it's going to hold a string. That's the only format it takes in. So, once you grab the input in string format, you have to convert it to an integer. Now, we aren't doing what we call exception handling. We're not checking for errors. If what the user enters is not parsable to an integer, you're going to have a problem. It's going to crash. But we're doing this just to learn what we're doing right now. Adding exception handling is really not that difficult. We'll talk about it in a later lecture. For right now, we're going to create this thing we call it an accumulator. What we're going to do with it is it's basically going to be the variable that keeps the running total as you go through getting items or getting data. So for int count equals 1, count less than or equal to days, count plus plus. You're going to grab the input again. It's going to be J option pane dot show input dialog. And enter the sales per day count. Right. So we're then going to take the sales, parse it, double dot parse double, pass it the input. And you're going to take total sales. This is our accumulator right here. It's a double. It's going to take the total sales. Oops, there should be count. The total sales and add it to itself plus whatever the sales is that the user added. Then at the end, after the for loop, I'm going to do a show message dialog. I'm going to say the total sales are $sign plus. Format total sales. So $, is the decimal format object that we used, and if you'll recall, we also need to call system.exit since we're using J option pane. It's just a requirement. So I'm going to run it. How many days do you want sales? Do you have sales figures for? Well, let's say 4. We'll say $500.25. 987.56, 223.44, it's a bad day, and then 200, say. So it'll tell us the total sales are $1,911.25. Right? Pretty straightforward. You're just looping through and continuously asking the user for a particular set of data. All right, so this is the logic for calculating a running total. You're essentially going through setting the accumulator to 0, going into the loop, read the next number, add to the accumulator. Is there another number to read? Keep going, keep going, keep going. When that ever becomes false, then you go out of the loop. It's important to note that there are different ways that loops work. Some loops are they work around a counter, like we've had many of the for loop, for example, and many of the while loops we've seen work around a counter. But sometimes the endpoint of the input data is not known. In this case, we'll use what's called sentinel-controlled repetition, and we'll use a sentinel value. Okay, this is like a flag value. It's a special value that doesn't occur in the regular input to notify the program that it needs to stop. If it is a user input, the user could be prompted to input that data that is not normally in the input data range. For example, let's say that the input has to be positive. Okay, so it's all positive grades, 0 to 100. Not, well, we'll say non-negative, 0 to 100. Then we could indicate that maybe -1 causes the program to terminate. So you'd say, well, input not equal to -1. Okay. And finally, I want to show you a nested loop. The nested loop is when you have a loop inside of a loop, right? So like if statements, loops can be nested also. If a loop's nested, the inner loop will execute all of its iterations for each time the outer loop executes once. For example, since we have this one right here, I would personally put curly braces around it, but this is probably for saving space on the slide. The outer loop goes 10 times, and then the inner loop also goes 10 times here, starting at 0, goes up to 9, and then exits, because 9 less than 10. When it gets to 10, this is no longer true. This loop right here will execute the 9 times. Then the outer loop will go on to its iteration number 1. Then this loop, as if it were just starting fresh, starts over at 0, goes 10 times. So this will go 100 times. For example, let's do an example so we can see how it works here. We're going to call this clock. Okay, clock. And we do need the scanner. So again, import java.util.scanner. Again, pay attention to where the what library the scanner lives in. Okay, or what package the scanner lives in, java.util. Inside here, public static void main string args. In here, we're just basically going to put a series of 3 nested loops. Int I equals 0. Actually, we're going to make this a little more useful. Int hours equals 1. Hours less than or equal to 12. Hours plus plus. Okay, so that's hours. And the next loop will be int minutes equal to 0. Minutes less than or equal to 59. And minutes plus plus. Okay, so the end for minutes. And finally, we have the seconds, which also goes up to 59. So for int seconds equals 0. Seconds less than or equal to 59. Seconds plus plus. Okay. And for seconds, I'm going to remove some of the space here. So be very careful to pay attention to what's going on here. Now, once we're in the seconds, we're going to print this out. We're going to just put system.out.printf. We're going to do a very skillfully formatted string here. We're going to put the percent symbol, remember percent and D for integer numbers. This means decimal. 0 to D colon percent 0 to D colon percent 0 to D, and backslash n. And the different variables here are hours, minutes, and seconds. Okay, let's look at what this does. If I run it, you notice that down here, it actually goes quite fast. And but if you scroll up here, you'll see it printed all the numbers just like a clock. It actually overflew the buffer here. So it just keeps going, and it deleted what it had originally. But you'll note that it does every single second, it prints it out. So it happened really, really fast. It only took a couple seconds to produce an entire day's worth of seconds. Okay, so you've got 3,600 seconds moving around in there. So that's quite a bit going on. All right, finally, since we're going to stop at slide 25, stopped at slide 25, okay. We're going to talk about the program 2 and then the midterm. I've uploaded your program 2 under Desire to Learn, and it's under Dropbox, just like your program 1. This program 2 is worth 125 points. It's due on Friday, March the 14th at 11:59 p.m. The objectives are to obtain user input using the scanner class. Please pay close attention to me when I say this. The scanner class, not JOption pane. Use the scanner class. To declare variables, to store data in variables and perform calculations, to understand and apply programming techniques related to control structures, specifically selection control, which are also known as decision control in the book, and repetition control or iterative control statements. These are the looping control statements. So the instructions. You're going to create a new Java source file and name it tempconvert.java. Okay, in addition to obtaining the user input using the scanner class, which is important, I don't want it any other way, you also should name your source file tempconvert.java. You will lose a significant amount of points if you do not name it what I ask you to name it. Okay, this is not me being a jerk. This is me trying to enforce what it's like in the industry. If you name it something completely different, it's unlike, and someone's expecting it to be named something else, it's going to cause everyone a lot of time, and in the industry, time means money. Several of you did not listen, did not pay attention to the instructions on the first in the first class. What you do, or the first program, what you do is you just name the new Java source file whatever you want to. In this case, tempconvert.java. You have to name it that, and it will create a class named tempconvert.java. The program, the source file, will actually match the name of the class. Okay, if one of them's off, one of them's different, you're going to get an error. For this assignment, you will write a program that will obtain user input via the command line. Okay, so scanner, right, to perform conversion between Celsius and Fahrenheit. So this will be an example. It'll prompt the user, say, enter 1 to convert from Fahrenheit to Celsius, enter 2 to convert from Celsius to Fahrenheit. Then you wait for the user to enter a 1 or a 2. Once you get a 1 or a 2, if it enters a 1, that means that they want to convert from Fahrenheit to Celsius. So that means you're going to display a table. You don't ask for any more input. You display a table starting at 0 degrees Celsius all the way up to 20. It says exactly what you need to do here, and then whatever the degrees Fahrenheit are. Okay? If they enter a 2, you put the degrees Fahrenheit over on the left side, because that's the determining value, from 32 to 52. So 20 different degrees of Fahrenheit, you should show it in degrees Celsius over here. Here are your required formulas. All right, you should be able to figure this out. Where there are variables, there probably are actual variables. Other requirements and hints. Note that the pound signs can be whatever the Fahrenheit or Celsius equivalents are. Please don't actually write pound signs. You will lose essentially all of the points. And I might send a mean note to you and, I don't know, put honey on your rear view mirror or something irritating and annoying. You must use both selection control structures, such as if, else, or switch, and repetition control structures, such as while, do while, and for. Do not hard code the converted values. If you do that, you will lose nearly all of your points. Okay. Again, the purpose of this assignment is to be able to use selection control structures and repetition control structures. All right. You can determine where you are using those. Don't overuse them just to use them. You should use them where they are necessary. Pay attention to your arithmetic. Integers and floating point values divide differently, so you have to take that into consideration. You must put comments at the top with your name, class, semester, and data. Please do that. Please put your name. Please put the class, CIS 1050, semester, winter 2014. Oh, that should be date. Sorry, not data. The date isn't quite as, I'm not as hardcore about that, but it should be date. You must name the Java file tempconvert.java. See, I wrote it again down here. There's no excuse to name it anything else. Okay? If you accidentally start on it and you're like, oh crap, I screwed up, you can rename the file. Right-click, refactor, rename. That's how you do it from within Eclipse. You can do that to any of these. Right-click, refactor, rename. You can rename it whatever you want it. Once you rename it, if it doesn't change it automatically, then you have to change the name of the class to whatever the name of the file is. That is required. All right. Deliverables, you'll upload your Java source file to assessments, Dropbox in desired alert. Please upload the Java source file. I had a few people upload the project file. I had a couple people upload other things that really had nothing to do with what you were supposed to turn in. You must find the Java source file. Okay. Midterm examination. Everyone ready? Midterm examination. The first, you're allowed a one 8.5 by 11 sheet of paper, both sides. You can put whatever notes you want on it. Any notes you want. It is not open book. It is not phone a friend. There's no poll the audience. The first question is worth 5 points. You need to understand the differences between output and input devices. Okay, I'd be able to identify output and input devices, printer, scanner, the monitor, things like that. Question number 2 is worth 5 points. You should know how to print data to the console, and you should know the difference between print and print line. Number 3 is worth 10 points. I give you some code and I tell you to fill in the code. It's very simple. So that means you should know how to declare things like integers, booleans, strings, doubles, stuff like that. And you should know how to assign values, and you should also know how to print values or print anything to the console using the print or print line methods appropriately in context. Number 4 is worth 5 points. You should know about all the different operators available in Java, the arithmetic operators. You should know about division. You should know about addition, modulus, multiplication, subtraction, etc. Number 5 is worth 5 points. You should know about constants in Java. What is a constant? How do you declare a constant? After you set its value, can you change it, etc. Number 6 is, now many of these are multiple choice. Everything, well, the first problem, number 1, is fill in the blanks. 2 is a question you have to answer. 3, you fill in code. But 4, 5, 6, number 6 is also a multiple choice. Number 6, you should know about the scanner class. Okay, you should know about how the scanner class. You should know about import statements. You should know about how to declare a scanner. What does system.in mean? You should know all of that. Number 7 is worth 5 points. You should know the methods of the scanner class. So 6 and 7 are both about the scanner class. Number 7, you should know about the methods for obtaining input from the scanner class. Number 8 is worth 5 points. You should know how to display input and message dialog boxes in GUI interface, so graphical user interface, not the console in this case, but where I'm asking about GUI interface. Number 9, you should know about arithmetic, relational, and logical operators. You should be able to distinguish and categorize them. You should be able to know, what is and is not a logical operator, what is and is not a relational, what is and is not an arithmetic operator. Those are 3 different categories: logical, arithmetic, and relational. Number 10 is worth 10 points. I give you 4 different choices. It's multiple choice. You should be able to look at some code. It's a very simple code. I will tell you that number 10 involves either selection control or repetition control. So either if statement, if else, switch, or it could involve for loops, while loops, or do while loops. That's what I'm going to tell you. And you should also be familiar with things like the addition operator, subtraction operator, and compound operators, and also the modulus and division for this code. You should be able to distinguish and know what different code means. Okay. Number 11 is worth 10 points. It is multi-part. It has 3 different parts, and it involves being able to understand the logic operators and what their resulting values are. So if I have one Boolean value and I say do a logical OR with another Boolean value, what will the output be? So you should know logical AND, logical NOT, logical OR, etc. Number 12 is 10 points. I give you the code, and you're supposed to identify a logic error in the code. So logic error is not code that will necessarily cause a compiler error, but it is, given the context of this code, you should be able to tell me what is the problem with the code. I will also tell you for number 12, you need to know about the data types we've talked about: integer, double, string. You should also know about things like how to compare strings. You should know about how to do a parse using integer.parse, double.parse, all that stuff. Any of that could be on number 12. Number 13 is worth 5 points. I give you code and I ask you what does it print out to the console. Specifically, on number 13, you should pay extremely close attention to the printf method that is available through system.out. You should know about the different flags and the different format possibilities that you can have with the printf. That's in chapter 3. So that one you definitely need to probably brush up on if you haven't used it a lot. You need to know about how to set the precision of a particular value. You should know how to insert commas. You should know how to round to different spaces. So that's the precision I was talking about. There's all kinds of different things you need to know. How to set the number in a particular width. These are all different things that could be available. So the format specifier, all of the stuff that's involved with the format specifier, you should know. So page 165 and, well, actually 164 and some of the ones around there might be helpful to you. Number 14 is worth 5 points. It also asks you what is printed out by the code. This one you need to know about selection control statements and iterative control statements. For example, the iterative control statements while, do while, and for that we learned today. You should know about those and how they differ and how they compare and contrast. And finally, number 15 is worth 10 points. I give you a set of code, and you should be able to identify errors. I tell you how many there are. So in this, you should be able to look through it and then determine what the errors are. I even, at one point, I actually kind of draw your attention to a particular location to help you see where the problems are. Okay, so that's your test. If you have any questions, please contact me. And if you have anything to ask me at all, just please contact me through email or contact me over the discussion boards. You can talk to your associates if you will, and just study for your midterm. Have a good break. Again, next week we do not have any lecture, so don't be looking for one. I will be probably taking a nap or making more, or eating Buffalo Wild Wings or making more materials for you guys. So you have a good day, and hope that you have a great rest of the week, and study hard and work on your program. Thank you, and have a great time.